Hello everyone and welcome back to the podcast. Today we are diving into a topic that I know has been a headache for a lot of people working with Microsoft Fabric. I am here with Arjun and Geet and we are going to talk about data sync issues.
Hey Shrest, yeah, this is a big one. The classic I just loaded data. Where is it? Problem.
Oh, tell me about it. You're in a notebook. You run your ingestion. Everything looks great. You switch over to the SQL endpoint to query it and nothing. It's like you're yelling into the void.
Exactly. It's one of the most searched issues I have seen. You update a table in the Lakehouse, but those changes just don't show up immediately in the SQL endpoint. It can be super frustrating.
And it's not just about interactive querying. Think about automated pipelines. You have a notebook that processes and loads data. And the very next step in your pipeline is a copy activity that needs to pull that new data. That activity often fails, or even worse, copies stale data because the SQL endpoint hasn't caught up.
Right? It breaks the flow of automation. You end up having to put in these awkward wait or sleep steps in your pipelines, just hoping that you've waited long enough. It feels like a workaround, not a solution.
That's the core of the problem. You're basically guessing. The documentation says it generally reflects changes within 15 seconds, but it can be more depending on the workload. And in a data pipeline, 15 seconds can feel like an eternity. And depending on the workload is not the kind of certainty you want.
Exactly. You need deterministic pipelines. You need to know that when step 1 is done, the data is ready for step 2. Otherwise, you're building on a shaky foundation. You get intermittent failures that are a nightmare to debug.
So, what's the good news, Shrest? The article you wrote suggests there's a better way now. I'm really hoping you're not going to tell us to just wait longer.
Haha, no, definitely not. The good news is that Microsoft recently shared an update that addresses this directly. We can now use the Fabric API to programmatically trigger a refresh of the tables right from our notebook.
Oh, that's amazing. So instead of waiting and hoping, we can just tell Fabric, hey, I am done. Update your metadata now. That's a game changer.
That's exactly it. It gives us control back. I decided to write the blog post because when I looked for this, the information was all over the place. Bits and pieces here, a GitHub repo there. I wanted to create a single go-to resource for how to do this properly from a notebook.
That's super helpful. A consolidated guide is always needed for these kinds of specific, technical problems. So let's get into it. How does it work? What's the first step?
Okay, so step 1 is getting our credentials and ID sorted. The nice thing is, if you're running this inside a Fabric notebook, it's surprisingly simple. We don't need to mess with service principals or complex auth flows for this method.
Wait, really? No service principal? I am already a fan. That's usually the most complicated part of setting up any kind of API interaction in Azure.
For this notebook-based approach, nope. We leverage the SEMP library, which is a fantastic Python library for interacting with Fabric. The code starts with some basic imports, JSON, notebook URLs, and of course, semp.fabric.
SEMP is great. It handles a lot of the context-aware stuff for you. So, how do we get the IDs we need? The workspace ID, Lakehouse ID.
It's almost too easy. You use the spark.conf.get method. For the workspace ID, it's spark.conf.get trid ent.workspace.id. For the Lakehouse ID, it's spark.conf.get trid ent.lakehouse.id. This will automatically pick up the IDs for the workspace and the default Lakehouse your notebook is attached to.
That's so convenient. So you don't have to go digging through URLs or portal settings to find these GUIDs and paste them into your code. It just knows.
Exactly. Now, the third piece we need is the SQL endpoint ID. This one is a little different. We have to make a quick API call to get it, but again, SEMP makes it easy. We instantiate the client with client equals fabric REST client.
Okay, so SEMP has a built-in REST client that's already authenticated as the user running the notebook. That's the magic right there.
That's the magic. Then you make a GET request to an endpoint that describes your Lakehouse. And from the JSON response, you pull out the SQL endpoint ID. The code in the article lays it out clearly client. Get for one workspaces/workspace ID lakehouses/lakehouse ID. And then you navigate the properties to find the ID.
Well, so in just a few lines of code, with no hard coding, you have your workspace ID, Lakehouse ID, and the specific SQL endpoint ID you need to refresh. That's a very elegant setup.
It is, and once you have those three IDs, you're ready to build and send the actual refresh request.
Alright, so this is the main event. What does that request look like? Is it a complicated payload?
Surprisingly, no. This is another area where I saw some confusing examples online. The URI is pretty straightforward. It's v1, 0 data marts/SQL endpoint. You just plug in the SQL endpoint ID you just fetched.
Okay, that makes sense. LH data marts, an interesting name for the endpoint. So what do we send to it?
The payload is a very simple JSON object. It's commands $type metadata refresh command. And that's it. You're telling the data mart, which is the SQL endpoint, to run a metadata refresh command.
That is simple. So you just wrap that URI and payload into a client.post call using the same SEMP client.
You got it. A response equals client.post URI, JSON equals payload. The SEMP client handles the authorization header, the base URL, everything. It's super clean.
I love it. This is the kind of API design that makes developers happy. So what happens when you send that request? What's in the response?
This is where it gets interesting, and it's the next big hurdle people face. When you make that POST request, the operation doesn't happen synchronously. It kicks off a background job.
An asynchronous operation. That's common with long-running tasks. So the initial response doesn't say success or complete.
Exactly. The response you get back immediately has a status, and if you check it, it will likely say in progress, and crucially, it gives you a batch ID. This ID is the key to the next step.
Okay, so you've kicked off the refresh, and Fabric gives you a ticket number, the batch ID, to check on its progress later. This is the part the article mentioned where you might wonder, what now? Do I just move on?
Right? You absolutely cannot just move on. If you do, you're back to the original problem. You're assuming the refresh is done when it might not be. You have to use that batch ID to poll for the final status.
This makes perfect sense from a systems design perspective. So you need a second API call to check the status. What's the endpoint for that?
The status check URI is slightly different. It's FV1, 0 data marts/SQL endpoint batches/batch ID. You see, it's the same base, but now you're targeting the specific batch you just created.
And I assume you just make a GET request to that status URI.
Precisely. Client.getStatusURI.json. The JSON response from this call gives you the detailed status of the operation. The key field you're looking for is progress state.
And you're hoping to see that progress state change from in progress to success or completed, or something similar.
Yes, the state you want to see is success, but you can't just check once. The whole point is to keep checking until it's no longer in progress.
And that's where the while loop from the blog post comes in. You're basically saying, while the job is still running, wait a little bit and then check again.
That is the robust way to do it. You set up a while progress state equals in progress loop. Inside the loop, you might have a time.sleep1 to wait for a second, so you're not hammering the API. Then you make the GET call to the status URI again. Update your progress state variable, and the loop continues until the state changes.
That loop is critical for a production pipeline. It turns an asynchronous fire and forget call into a synchronous blocking operation within your notebook. The code won't proceed past that loop until the refresh is confirmed to be complete. This is the reliability we were looking for.
So, once the loop finishes, you check if the progress state is success. And if it is, you can finally be confident that the SQL endpoint is fully synced with the latest data from the Lakehouse.
Yes, and the response object you get when it's successful is really rich. It contains a lot of information. The article shows how you can parse this to get details for each table. That was part of the refresh operation.
That's useful for logging and auditing. You can see which tables were refreshed, what their sync state is, and if there were any warnings. The example in the article shows passing out table name, table sync state, SQL sync state, and last successful update.
Having that last successful update timestamp would be so valuable for debugging. You have definitive proof of when the sync happened.
Exactly, it provides that audit trail. And if the progress state comes back as failure, the response object will contain detailed error information, which is obviously crucial for troubleshooting.
Okay, this all sounds incredibly logical and powerful. But the article mentioned a big gotcha, or a consideration, something that could still confuse people. Let's talk about that.
Yes, this is probably the most important nuance to understand. I even put a DMA, TF, in the blog because it can be confusing. The API call to refresh the metadata doesn't necessarily refresh every time you call it.
Wait, what? After all that, it might not even run. Why would it not run?
It only performs a true refresh if there has been an actual change to the underlying table data or metadata since the last refresh. If you haven't inserted, updated, or deleted any data, the operation essentially gets skipped.
That's an optimization. It's smart, but I can see how it would be confusing. So if you run your ingestion notebook, then run this refresh script, it will work. But if you immediately run the refresh script a second time without any new data changes, what happens?
In that second run, the final status for the tables will be not run instead of success. And this is the key. The overall API call will still report success at the top level. But when you look at the details for each table, the table sync state and SQL sync state will say not run.
Ew, wow. So you could be looking at the last successful update timestamp and wondering why it's not updating to the current time. You'd think your script is broken, but it's actually Fabric telling you, hey, there was nothing to do.
That's it exactly. I spent a good amount of time figuring this out. I kept running the script and wondering why the timestamp wasn't changing. It's because there were no new transactions on my tables. The moment I inserted a single new row and ran it again, boom, the state changed to success and the timestamp updated.
That is a critical distinction. So the takeaway is don't just check the top-level API status. You need to inspect the table sync state for the specific tables you care about. Success means it refreshed. Not run means there were no changes to apply.
This makes so much sense now. And it's actually a good thing. It prevents unnecessary processing, but you have to know what to look for in the output. The JSON examples in the article showing the difference between a success state and a not run state are super helpful for this.
I thought it was important to show both. In the success case, you see table sync state and SQL sync state as success, and the last successful update is the current time. In the not run case, those states are not run, and the last successful update timestamp is an old one from the last time it actually did change.
So, thinking about the bigger picture, this technique seems perfect for scenarios where you're using a notebook for your transformations. It fits right in. You mention in the article that for non-notebook scenarios, one might need to look at other auth methods.
Yes, This SEMP method is so clean because it uses the notebook's user context for authentication. If you wanted to call this API from, say, an Azure function or some other external process, you would need to set up proper service principal authentication to get a bearer token to call the API. The official Microsoft GitHub repo has examples of that.